This recording is for Algebra 1, Chapter 2, Lesson 6, and Lesson 6 only. These are what we call mixture and solution problems. They are one variable that happens multiple times in the same equation and you have to solve for it type problem. So expect to see multiple variables but the same variable. So it just happens more than once. So the big thing that you do need to know about real quick is kind of a weird concept that sometimes people have trouble wrapping their minds around, so I'm going to spend just a minute talking about it, is comparing an amount to a whole to determine a second amount. So basically, when comparing two amounts to a whole, one amount is equal to the whole or total minus the second amount. So if we look at a total, let's say this total is 300, and I'm going to fill it with some red solution. So this is like 100 liters of red solution, and it's red. If I want to find out the amount of teal solution, so how much of the solution teal do I need, it's basically going to be the total, 300, minus how much red solution I have, and that's going to equal the teal solution, okay? So if I really didn't know how much red solution I needed, maybe I don't know that I have 100 liters. Maybe I know that I have a amount of red solution, and I still need to figure out how much teal solution I need. It's going to be the total minus A equals the teal solution. And this is going to come in really handy on the very next slide. So make sure you're mulling this over as I go to the next slide. Okay, next slide. Hope you mulled it over. All right. So this is what we call a classic mixture problem, and mixture problems are usually like nuts and raisins, like trail mix, like trail mix stuff. Hopefully you've all had trail mix, unless you're allergic to something that trail mix is always in, but whatever. All right, so this is a mixture problem, and it says raisins cost $2 per pound and nuts cost $5 per pound. How many pounds of each should you use to make 30-pound mixture that costs $4 per pound? So if you're like in the grocery business or like the whole, like the natural food business, and you like to make your own trail mix and you want to sell it, this is something that you might actually do on a regular basis. This is what we call a real world problem, where somebody at some point had to do a problem almost exactly like this. So that's kind of cool. Okay, so how do we set it up? So what I'm going to do is I'm going to make R the number of pounds of raisins I need to make my total mixture. All right. So the thing is that there's only two things in my mixture. I only have raisins and I only have nuts. The thing is that the amount of raisins I use is going to affect the amount of nuts I use, because I still want to make 30 pounds. So some of that weight has to be taken up by the raisins, and the other weight that isn't the raisins has to be taken up by the nuts. This is going back to the red and the teal mixture from the solutions from the previous page. So whatever is not raisins is nuts. So if I take 30 and I subtract R, I'm going to get the amount of nuts I need. All right? So that would be 30 minus R. And by the way, over here in the cost per pound, that's just how much the raisins cost before they go into my mixture, and the cost of the nuts before they go into my mixture. So the mixture itself, though, needs to be a total of 30 pounds and needs to cost $4 per pound. Basically, I'm setting up this chart because it's going to get me what the cost thing is going over here on the right, and that's what's most important. So the cost for raisins is going to be $2 per pound. So if I have 2 pounds, it's going to cost me $4, because 2 times 2 is 4. So there we go. That's how it's going to go in there. And then the cost for the nuts is $5 per pound, but obviously we don't know how many pounds there are, but it is related to the number of raisins, because it's subtracting. We've got the total minus the raisins. Well, the total minus the raisins is really how much nuts I need. $5 times the number of pounds of nuts I need gives me the cost of the nuts. Now we need the cost of the final mixture, because we need to know what all of this is being compared to. So if I've got 30 pounds and it's $4 per pound, that's going to give me the total cost of all 30 pounds. But all of this is related somehow, because I need to figure out how many pounds of nuts and raisins I need. So basically the cost of the raisins plus the cost of the nuts, depending on how many pounds I get, is going to equal the cost of the mixture. So it's basically, that's the important information. And again, it's the cost of the raisins plus the cost of the nuts is going to equal the cost of the total mixture, right there. There we go. And actually, so it's this plus this equals that. Okay, and I think that'll come up again, so it might look a little weird over there. So let's go ahead and solve for r. I'm going to distribute, and I'm going to get 2r plus 150 minus 5r equals 120. I'm going to combine like terms, my 2r and my negative 5r, and that's going to give me negative 3r. Negative 3r plus 150 equals 125. Subtract 150, subtract 150. Divide by negative 3, divide by negative 3. Guess what? I'm going to get 10 pounds of raisins. R equals 10. And just remember what your variable is. And writing a little note to yourself at the beginning before you start the problem might help you remember what R is. R is pounds, and it's pounds of raisins. So when R equals 10, that means we have 10 pounds of raisins. So keeping an eye on what your variable means can be very helpful in the long run. So if I've got 10 pounds out of 30 pounds of raisins, how many pounds of nuts that is? Well, that's just 30 minus 10, which is 20 pounds of nuts. So I'm going to have 10 pounds of raisins, 20 pounds of nuts. And this should make sense. The total mixture amount should add up to how many, pounds I need at the end. So this should make sense. I shouldn't have like 300 as one of my answers, because 300 pounds would put me over my 30-pound limit. So you have to make sure your problem and your answer you have to make sure your answer makes sense to the problem itself. So don't forget that. It's highly important, guys. I've had a lot of people mess up on that, where they're like, oh, it's a totally reasonable answer. And I'm like, that answer makes no sense. So make sure your answer makes sense. All right. There we go. What does this say? The answer should make sense. Yeah, what did I just get done rampaging about? Make sure your answer makes sense. Okay, last slide. Last slide. Okay, so this is a percent solution problem. And anybody who's going to go into science and chemistry, let me tell you, you need to know how to do these problems for Intro to Chemistry. So anybody who takes chemistry in high school, you're probably going to need to know how to do this. If you take chemistry in college, you're definitely going to need to know how to do this. So pay attention. Okay, so this is a solution percent problem. A chemist has 10% acid solution and a 60% acid solution. How many liters of each acid solution does the chemist need to make 200 liters of a solution that is 50% acid? So let's go ahead and start filling information into your chart. And again, some of you might not need this chart. I personally need this chart. I make the chart every time I'm doing these problems. It helps me organize my thoughts. You don't have to, but if you're having trouble with these problems, I highly recommend making the charts. Okay, so how many liters of the 10% solution do I need? Well, I don't know. So I'm going to make it a letter. I'm going to go ahead and make it S. Now again, you can make either the 60% your variable and the 10% your 200 minus the variable. It doesn't matter. You just need to make sure you set it up for yourself. I'm going to do it this way. It's your choice whether you do it. Again, it's the mathematician's privilege to choose which one gets the variable. All right? So in this case, I made S the number of liters needed for the 10% of the 10% solution. And I made 60 the 200 minus S, because if it's not 10%, it's got to be the 60%. And I do know that the final solution, that is 50%, should be 200 liters. All right, so let's figure out what the percent acid is. I always set it up as a decimal, because decimals are pretty easy, especially when you've got calculators. Oh, I showed you way too much. Let me get rid of that. Okay. Oh, I just hit the wrong button. That was my bad. Okay, so there we go. Okay, so now the percent acid is, for 10% is 0.1, because as a percent, 0.1 is a decimal, right? 0.6 is a decimal for 60% and 0.5 for 50% as a decimal. Okay, so multiply across. 0.1 times S is the percentage of the acid when I have S liters of it. 0.6 times the quantity, 200 minus S, is the percent acid with the amount of liters of the 60% I need, and 0.5 times 200 is 0.5%, 50% of acid, 50% acid when I have 200 liters. Again, this is the same important information from the last problem. It's the final column that's important, and it's going to be this plus that equals that. So 0.1 S plus the quantity of 200 in S times 0.6 equals 0.5 times 200. So there's the equation right there. It's what I just got done saying, so I'm not going to read it again. You need to distribute, and you need to combine like terms. You need to solve for S, and you're going to get S is 40. So we need 40 liters of the 10%, 40 liters of the 10%, and 200 minus 40 is 160, which means we need 160 liters of the 50% acid. All right, guys, good luck with these problems. They're kind of mind blowers sometimes. So if you're having a problem, definitely make the chart. The chart will help you organize your information. All right, have a good weekend because I'm recording this on a Friday. Bye.